Placentation. The method of arrangement of ovules in the ovary of gynecium is called placentation. Part of the ovary that bears ovules is called placenta. Placentation is of following types: 1. Marginal, 2. Parietal, 3. Axial, 4. Free central, 5. Basal, 6. Superficial placentation. Marginal placentation. The ovules are borne along the ventral structure of the ovary. It is found in unilocular ovary. Example, dolichos. Parietal placentation. The ovules are borne on the inner walls of the ovary or on intrusions of the wall that form incomplete partitions or 4 septa within the ovary. It is also found in unilocular ovary. Example, brassica, cucurbita. Axial placentation. The ovules are attached to the central axis of the ovary. It is found in bi- to multicarpellary ovary. Example, hibiscus. Free central placentation. The ovules are borne around the central axis freely. It is developed from axile placentation with the degeneration of septa. The ovary is multilocular in the young stage and unilocular in the mature state. Example, dianthus. Basal placentation. The ovules are borne at the base of the ovary. In this, one or few ovules are present. It is also found in unilocular ovary. Example, tridacts, helianthus. Superficial placentation. The ovules are borne all round the inner surface of the septa. Example, nymphea. Style. It is an elongated part of the gynecium present between ovary and stigma. Depending upon the position, the styles are of 3 types. 1. Terminal, 2. Lateral, and 3. GYNOBASIC style. Terminal style. The style arises from the apical part of the ovary. Example, hibiscus. Lateral style. The style arises from the lateral side of the ovary. Example, mangifera. GYNOBASIC style. Style arises from the base of the ovary in between the 4 locules. Example, ocimum. Stigma. It is the terminal part of the gynecium. It receives pollen grain at the time of pollination. It secretes substances during fertilization. Pollen grains germinate on the stigma by absorbing stigmatic secretions. This concludes the study of flower. Now it is time for fast revision of very important points from this chapter.
Flowers come not only in a variety of shapes, but also in a variety of types. Have a look at these flowers, for example. Aren't these beautiful masterpieces different from the conventional ones that we usually glance at? Yes, and since they are totally different, this type of arrangement is given a special name as well. Such an arrangement of a cluster of flowers on a stem is called inflorescence. Let's understand this beautiful concept in detail. Can you help me with the definition to begin with? What exactly is inflorescence? That's right. We would prefer taking an example. Let's take this same flower. As we can see here, there is no single flower at the apex of the stem. Rather, small flowers cluster and form a complete structure. Although this is not the perfect analogy, But just to understand, we can relate this to the pinnately compound leaves. Remember their structure? Yes, this is how they appear. As the small leaflets arrange themselves and give us this complete structure, similarly here, these small flowers make up the complete inflorescence. Please note that the pinnately compound leaves and inflorescence are just considered to understand the concept better. We are neither comparing nor relating the two. Getting back to our concept, the flowers form a group along the stem or at the apex to form the inflorescence. Now tell me, will the structure of the flowers at apex form an inflorescence or along the stem? I mean, will this be called as inflorescence or this? To our astonishment, both of these are inflorescence. Let's understand these types in detail. The first type is where the flowers are arranged laterally along the central axis. The most important point to note here is that the apex or the terminal point of the shoot does not bear a flower. That means it can freely grow indefinitely. Such a type is called racemose inflorescence. Here, the arrangement of the flowers is alongside the central axis, leaving the apex free. In this type, the older flowers are found near the base, while the newer ones start developing towards the apex. Now, since the apex can grow continuously and indefinitely, this type is also called as indefinite inflorescence. So can you guess what could the next type be? That's right. It will be the opposite of this. Thus, it will be definite inflorescence, the type we see in this case. As we can see here, apart from the ones along the central axis, a flower even develops at the apex. As a result, the growth of the shoot does not occur indefinitely as in the first case. This type is called the cymose inflorescence. As we can see here, the apex is occupied by the older flowers, while the newer ones start shooting from the secondary branches that are formed. So this type has older ones at the apex and the newer flowers at the base, in contrast to the racemose inflorescence. To summarize, we find these flowers exhibiting racemose and these exhibiting cymose inflorescence. These typical patterns of arrangement help us study the plant in many ways.